Preparation of dihydrogen. First of all, let us discuss the general methods of preparation of dihydrogen H2. The first method is by the action of water on metals. The various metals differ in their reactivity, and therefore the various metals react with water to form hydrogen under different conditions. For example, A. Very active metals like sodium, potassium and calcium react at room temperature to evolve hydrogen. The reaction is 2Na plus 2H2O gives 2NaOH plus H2. Similarly, 2K plus 2H2O give 2KOH plus H2. Now these reactions are highly vigorous and exothermic, and therefore the hydrogen evolved catches fire. Then the B. Less reactive metals like zinc, magnesium, aluminium, etc. can liberate hydrogen from water only upon heating. Okay, so you can see that in the first case the reaction is spontaneous, it is highly vigorous and highly exothermic. But in this case, the less active metals like zinc, magnesium, aluminium, etc. can liberate hydrogen from water only upon heating. So Mg plus H2O, heat gives MgO plus H2. Similarly, Zn plus H2O gives ZnO plus H2. 2Al plus 3H2O on heating gives Al2O3 plus 3H2. Then C. Metals like iron and nickel can react only by passing steam, okay, because these elements are very less reactive. And this is a very famous reaction, 3Fe plus 4H2O. Now this 4H2O is from steam. It gives Fe3O4 plus 4 hydrogen. The reaction between iron and steam is used for the large scale preparation of dihydrogen, okay, by Lane's process. This process is called Lane's process, Lane, okay, Lane apostrophe S process, Lane's process. Then the second is by the electrolysis of water. The second method is by electrolysis of water. Dihydrogen of high purity is mostly prepared by the electrolysis using platinum electrodes in the presence of a small amount of acids or alkali. The reaction is very simple. 2H2O liquid on electrolysis is give 2 hydrogen gas plus O2 gas. Now in this case, you know very well, you have already done. During the electrolysis, dihydrogen is collected at the cathode and dioxygen is liberated at anode. The following reaction takes place. You know that when we take water, this water H2O dissociate to give H plus OH minus. Okay. Now at cathode H plus accept one electron to give hydrogen. This is a primary change, and this hydrogen plus hydrogen give H2 gas. So you must understand that hydrogen gas is liberated at the cathode. Now at anode oxidation takes place. You have already done oxidation reaction, reduction reaction, okay, in the redox reaction. Now 4OH minus 4 electron, it will lose electron, okay, then it will give you 4OH, and this 4OH will give you 2H2O liquid plus O2 gas, okay. So that way hydrogen is prepared. Now we must understand that hydrogen prepared by this method is of very high purity, okay. Now the third method is by the action of alkalis on metals. Okay, we have discussed the first two methods. Now let us discuss the third method by the action of alkalis on metals. You know, metals like beryllium, aluminium, zinc, tin, etc. will react with strong alkalis like NaOH, KOH to evolve hydrogen. The reaction you can learn is the very important reaction is Zn plus 2NaOH. Okay, this is very important. Please remember this reaction. Zn plus 2NaOH. This gives Na2ZnO2 plus H2. Okay, Zn plus 2NaOH gives Na2ZnO2 plus H2. This is sodium zincate. Sn plus 2NaOH plus H2O gives Na2SnO3 plus 2H2. This is sodium stannate. Similarly, 2Al plus 2NaOH plus 2H2O, this gives 2NaAlO2 plus 3H2, and this is called sodium meta-aluminate. Then the fourth method. The fourth method is by the action of metals on acids. Okay. Now the active metals like Zn, Mg and iron, zinc, magnesium and iron, react with mineral acids such as hydrochloric acid and sulfuric acid to evolve hydrogen. This is a very common method. The reaction is Zn plus H2SO4 gives ZnSO4 plus H2. Mg plus 2HCl gives MgCl2 plus H2. Similarly, Fe plus 2HCl can give FeCl2 plus hydrogen. So these are some of the general methods of preparation of dihydrogen. Now let us discuss laboratory preparation. So this is method number 5. This method number 5 is laboratory preparation of dihydrogen. Now hydrogen is prepared in the laboratory by the action of H2SO4, dilute H2SO4 on granulated zinc. Okay, the reaction is very simple. The reaction is Zn plus H2SO4 dilute. This gives ZnSO4 plus H2. Now, the diagram is given here. You can just look at the diagram, and from the diagram it is very clear. Okay. Then let us discuss preparation of pure hydrogen. Okay, preparation of pure hydrogen. Now, very pure hydrogen, that is more than 99.95%, may be obtained by the following methods. Okay, number 1, the first method in this case is by the electrolysis of warm solution of barium hydroxide BaOH whole twice using nickel or platinum electrodes. This is number 1. Then number 2, by the action of potassium hydroxide on scrap aluminium. The method is 2Al, the reaction is 2Al plus 2KOH plus 2H2O. This gives 2KAlO2 plus 3H2. Now this method is known as Yeno's method. UYENO''S, Yeno's method. This method is used for preparing hydrogen for military purposes. Then the third is by the action of pure dilute H2SO4 on magnesium. So magnesium ribbon, that is Mg plus H2SO4 dilute, this gives MgSO4 plus H2. So these are the methods by which the hydrogen is obtained in the highest state of purity. Then we have commercial preparation of dihydrogen. Now commercial preparation of dihydrogen we will discuss in the next meeting.